So today we're going to talk about the Pythagorean Theorem. We're going to use the Pythagorean Theorem and its converse to solve problems, and we're going to use Pythagorean inequalities to classify triangles. So it says the Pythagorean Theorem is probably the most famous mathematical relationship. In a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So remember, the hypotenuse is always the side that is across from the 90-degree angle. So in this case, a squared plus b squared is equal to c squared. So we have what's called Pythagorean triples. And Pythagorean triples are a set of three non-zero whole numbers that we're going to call A, B, and C, such that a squared plus b squared equals c squared. So a few examples of Pythagorean triples are 3, 4, and 5. Also 5, 12, and 13. 8, 15, and 17. And 7, 24, and 25. So these three make right triangles. If I know that two legs are 3 and 4, then the hypotenuse has to be 5. Two legs are 5 and 12. I know the hypotenuse has to be 13. Alright, so let's look at some examples using the Pythagorean theorem. So let's first start with the first one. I'm going to go ahead and take my triangle and label the sides A, B, and C. I know C has to be across from the 90-degree angle, so this one is C. And then it doesn't matter which one of these are A and B. So I'm going to take a squared, so 2 square root of 7 squared, plus b squared, which will be the square root of 35 squared, equals c squared, which in this case is x squared. So 2 square root of 7 squared would be, well, 2 squared is 4, and the square root of 7 squared is 7. Plus the square root of 35 squared would just be 35, and that would equal x squared. So 4 times 7 is 28. So I would have 63 equals x squared. So x equals the square root of 63. And we do need to reduce the square root. So I know that 63 is the same thing as 9 times 7. And I can take the square root of 9. And the square root of 9 is 3. So this would be 3 square root of 7. So this should be 7. So x is equal to this 3 times the square root of 7. Let's look at example B. In this case, there should be a little line right here. I'm sorry, guys, I didn't quite print out, and also right here. So I'm looking for x. I know that this length is 12 and this whole length is 22. So that means this part right here has to be 12. So it looks like there's 10 left over for these two sides. So that means this part is 5 and this part is 5. So I'm going to go ahead and label my sides. It looks like I have C, A, and B. So 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. X squared equals 144. So x equals the square root of 144, which in this case is 12. Alright, let's look at letter C. I have C across from a 90-degree angle, and then A and B. So I have x squared plus 2x squared equals 15 squared. So this would stay x squared. 2 squared is 4, and then x squared equals 225. And then x squared plus 4 squared is 5x squared equals 225. So x squared equals 45. So x equals the square root of 45. But I know I need to reduce the square root, so I can change this into the square root of 9 times 5, which means the square root of 9 times the square root of 5, which gives us x equals 3 square root of 5. Alright, let's look at the last one. C is across from the 90-degree angle, and then I have A and B. So I have x squared plus 6 square root of 2 squared equals 10 square root of 2 squared. So I keep my x squared, and then 6 squared is 36, and the square root of 2 squared is 2, and that's going to equal 10 squared, which is 100, and the square root of 2 squared, which is 2. So now I'm just going to simplify. Sorry, guys. And then get x squared by itself. And then x would equal the square root of 128. And then I know I have to simplify the square root of 128. So that's the same thing as, let's see, 64 times 2. And I know that the square root of 64 is 8, so it'd be 8 square root of 2. Alright, let's turn this paper over. Let's look at the back side. We have some word problems. So it says, if a 15-foot ladder is placed up against a house, the base of the ladder is 9 foot from the base of the house. How far up the house does the ladder reach? So I have a house, and I have a 15-foot ladder, and it is 9 feet away from the house. And this is a right angle because we're going to measure straight up and down. We want to know how high up the house the ladder is. So I know this is going to be C. This is going to be A and B. So x squared plus 9 squared should give me 15 squared. So x squared plus 81 is equal to 225, and then x squared would be equal to 144. So x would be equal to the square root of 144, which is 12. So the ladder reaches up 12 feet. Number B, a flagpole that was originally 24 feet tall was cracked 9 feet from the ground and has fallen as if hinged. Find out how far from the base of the flagpole the top of the flagpole touched after it had fallen. So I had this flagpole that was 24 feet, but it cracked at 9 feet. And it fell, and I want to know how far this is from the base. So it was 24 feet, so 24 minus 9 gives me 15 left over for right here. So I want to know this length. So I'm going to let this be A, B, and C. So x squared plus 9 squared equals 15 squared. This is the same problem as up here. X ends up being 12 feet. Alright, so let's look at Pythagorean inequalities. So if a squared plus b squared does not equal c squared, then I know that my triangles are either right or obtuse. If it does equal c squared, then it is a right triangle. But if I have a triangle where c is the length of the longest side, which we know it is because it's across from the 90-degree angle, it's the hypotenuse normally. we have two options. We can have if c squared is greater than a squared plus b squared, then triangle ABC is obtuse. If c squared is less than a squared plus b squared, then triangle ABC is acute. So let's do a couple of examples like this. Let's look at letter 8. So out of 8, 11, and 13, 13 is the biggest, so it's our C. So c squared, and I want to know if it's greater than or less than 8 squared plus 11 squared. Well, 13 squared is 169, and then 8 squared plus 11 squared would be, let's see, 64 plus 121, which would give me 185. So in this case, 185 is greater than. So c squared is less than a squared plus b squared. So that means that this is an acute triangle. Let's look at the next one. If I multiply this out, this 3 square root of 3, I get something like 5.1. So it looks like 6 is the biggest side, so it'll be our C, and this will be A, and this will be B. So 6 squared, I need to see if that's bigger than, greater than, less than, or equal to 3 squared plus 3 square root of 3 squared. So this is 36, and then 3 squared is 9 plus, let's see, 3 squared is 9, and then square root of 3 squared is 3. So is 36 greater than 9 plus 27? It's 36 something to 36. Looks like these are equal, so this would be a right triangle. And let's do the last one. 16 is my biggest side, so it's C, so these would be A and B. So 16 squared, and then 7 squared plus 12 squared. Well, 16 squared is 256, and then I have 49 plus 144. And then, let's see, 256, and then, let's see, these are 193. So 256 is greater than 193, so C squared is greater than A squared plus B squared. So in this case, this would be an obtuse triangle. That is all.